What's up, guys? Welcome back. In this question, we have to figure out what values of k will the function x squared plus kx equals -9 have 1 root, 2 roots, 0 roots. So if you remember, this question deals with the discriminant, and I would actually highly recommend you go and watch some of the videos in that discriminant section, especially the last few, because the questions can get pretty complex. This question is actually not bad compared to the lecture videos, but some of them can get pretty bad and you never know what can come up on your test. So I'd recommend going back and watching those videos. But if you feel pretty confident with it, feel pretty comfortable with how a discriminant works, then just do the test questions. Anyway, so we got this function x squared plus kx equals -9. First thing you want to do is bring the -9 over. So you got +9 is equal to 0. So from here, they're saying what values of k will this quadratic equation have 1 solution, 2 solution, 0 solutions. So again, we just throw it into the discriminant. So in this case, the a value is what? 1. The b value is what's in front of the x, the k, and then the c value is 9. So if there is 1 solution, we know that the discriminant, which is what? B squared minus 4ac, is going to equal 0. So plugging everything in, plug in k for b, plug in 1 for a, and plug in 9 for c, we end up getting k squared minus 36 is equal to 0. Right? Then from here, we can factor this. You could bring the -36 over, square root both sides, but a lot of times, sometimes it's not going to be a smooth, or there's going to be a b value in this remaining quadratic. So you're not just going to be able to bring the c value over, square root both sides. Sometimes you have to factor this or even put in a quadratic formula. So I'd recommend keeping everything on one side, and if you could factor it, which you can in this case, this is just a difference of squares, right? Do it this way. So from here we could tell k is 6 or k is -6, right? K minus 6 equals 0, which means k is equal to 6, or k plus 6 is equal to 0, which means k is equal to -6. So those are the two answers for number 1. So k can be plus or minus 6. Because if k is 6, then the discriminant, or minus 6, then the discriminant is going to be 0 every time. Right? What if there's 2 roots? Well, if there's 2 roots, we know that the discriminant has to be greater than 0. So we could just keep all of our work here and just change this to greater than 0. Right? And that's actually another advantage of keeping everything on one side. Because if you remember, when you're looking at it when it's greater than 0, this is a quadratic here. So I would actually recommend drawing this. So the two intercepts are at +6, -6. So -6, +6. And it's opening up. So it's quadratic that looks like this. Right? And then the vertex should be here. Right? This is not necessarily to scale, but the vertex would be at 0 and -36. If you remember, back in the lecture videos, when we talked about quadratics, I mentioned if there's no b value, so if you're just dealing with an a value and a c value, the vertex is always going to be 0 and then the c value. And the c value in this case is -36. Right? And it's opening up because the a value is positive. It's just 1 there. Right? And then the two intercepts are at -6 and +6. So we know that this is equal to 0 at -6, +6, right? We already got that for number 1. When is it greater than 0? Well, in this section and that section. When is it above the x-axis? So that's going to happen when k is less than -6 or when k is greater than +6, this section over here. So that's the answer for number 2. That's when this quadratic equation is going to have 2 roots. And if it has 0 roots, we know the discriminant is what? It's less than 0. It's negative. Right? Meaning that that portion of the quadratic formula that's under the square root is going to be negative, and we can't square root a negative number. Right? That's why there is no solutions. Remember the discriminant? It's just the portion of the quadratic formula that's under the square root. So if it's less than 0, we can't square root it, and that means there's not going to be any solutions. So basically, when is this quadratic less than 0? Well, if we look at the graph, it's less than 0 in this region right here. So basically when k is between -6 and +6. All right, and those are your 3 answers. So way you want to do these types of questions, bring everything to one side, get your A, B, C value, and then plug it into the discriminant. And then the discriminant, usually what will happen, not always, but usually you'll end up getting a quadratic here. And then with the quadratic, you can, all you need is basically, is the quadratic opening up or down? So it's opening up because the A value is positive, and then you just need the intercepts. In this case, if factored smoothly, -6, +6 are the intercepts. And then visually you could see when is the discriminant greater than 0 above the x-axis, when is it equal to 0 at the intercepts, and then when is it less than 0 below the x-axis. But as I mentioned, I'd recommend going back to the lecture videos and watching those last few examples because they can get pretty complex.